Welcome to the Fundamentals of Mathematics fourth session, where we are now looking at the theory of sets. This session we are introducing more definitions on the theory of sets. I am your host, Upe Kolosa. Our work is outlined as follows. We will first look at the definition of what a finite or infinite set is. Remember, in the earlier sessions, we used the terms countable and uncountable sets. These terms can now be closely related to finite and infinite sets. We will see that under this will also emanate how the number of elements in a particular set is found. We'll further talk about subsets and supersets, and we'll end this session with a concept on equal and equivalent sets. Let's begin with the fun. Definition. We have the definition there for finite and infinite set. Before that, we know that when something is finite, then there is an ending to that something. And when it is infinite, there is no ending. Talking of an infinite number, we say that it can be any big number, but what is this big number? It can be 1,000. 1,000 is a big number, but it is not the last number. There's a 2,000 and other big numbers. So what is this infinite? We therefore say that a set is finite if it contains a finite number of elements or no elements at all. Otherwise, that set is going to be infinite. So we can say maybe let A be the month. So we can say let this set A be equal to the months in a year. So we have January, February, all the way up to December. So is this a finite set or an infinite set? So look at the elements that we have. We're saying we have the months of the year, January to December, and the year has 12 months. This implies that we have a finite set, because if we count the elements, we are going to have 12 elements. That leaves us that a set A is a finite set. Look at set B. We have set B, which is a 1, 2, 3, dash, dash, dash. Is set B a finite set or an infinite set? Can we count the elements that are in set B? We have 1, 2, 3, comma, dash, dash, dash. Remember, the dash, dash, dash means that the number keeps on going to an infinity. Therefore, this set B is an infinite set. Can I have another example? C. Let C be an element X such that X is a river. Nice example. In the world. In the world. Let C be a set with an element X such that this X is a river in the world. Is set C a finite or an infinite set? What do you think? You can take a second and think about this. Well, set C is a finite set. You may be wondering how many rivers are there in the world. There are so many rivers that we have in the world, but what you should know that these rivers in the world are countable. You may have some difficulties in counting them, but if you start going country by country, province by province, seat by seat, you'll find that you reach a finite number. Therefore, set C is a finite set. Okay, we can now move on. Therefore, it is only possible to count the number of elements in a finite set. And this number of elements is what is called the cardinal number. This number that we have here. The number of elements that you have in a finite set. So if you are asked to give the cardinal number of a set, you are simply being asked to state the number of elements in the set. Remember that the set has to be finite. It has to be a finite set for you to give that cardinal number. So let's assume we have the sets. Let's assume we have the sets A is equal to, we have a 2, 4, 6, and 8. Could you give the cardinal number of this set? That is the number of elements. First of all, you have to understand that you have a finite set. So is this set a finite set? Yes, it is, because we are having the number of elements that we can count. Now, what is this cardinal number? The cardinal number that we are now going to denote by the number of elements in A. And this is going to be equal to 4. Again, we can have set B, which is equal to A, B, and C. What is the cardinal number of the set? So the cardinal number that is now going to be denoted by the number of elements in B. And this is going to be equal to 3, because we have 1, 2, 3 elements in it. Okay, so now we can keep on moving. We also mentioned to say a set with no element in it is finite, and this type of set is called an empty set or a null set. The other term you can come across of the empty set or the null set is the void set. And this set is denoted by the empty curly brackets. This is how we denote the empty set, or the symbol phi can be used to denote the empty set. Remember, this is a set that we looked at the time we were looking at the notations. When we looked at notations, we defined an empty set to be denoted by this. And we're saying that this empty set is considered to be finite, and it is a subset of every other set. So suppose you've been given set A. By subset again, during the notations, we introduced what the subset is, the elongated C. And this is where we said you have a set inside another set. So this empty set is a set that is in every other set. So if you have set A, you therefore have the empty set to belong to the set A, always. Okay, so again we have the note here. Note that the set is not an empty set. So if this set is not an empty set, what is it? We have a 0 in it. This set is not an empty set because this 0 in it implies an element. So a set with one element in it is called a singleton set. Singleton set. So this is a set with one element in it. So So there is a very big difference between this set that we have here as a singleton and this set, which we are calling the empty set or the null set. Here, an element in it, one element called the singleton set, no element called the empty set. Okay? Consider the set. Okay, we have the set there. Set A is equal to an element x such that x is equal to 2, such that x squared is equal to 4, and x is odd. What do you think about this before we go to the subsets? Is this set an empty set, or is it a finite set or infinite set? Okay, let's define these elements x. So we are saying that x is odd. We know what the odd numbers are. So we can begin 1, we have 3, we have 5, we have a 7. Let's just use those 4 first. And we are saying that this x is defined by the expression x squared is equal to 4. So let's get one x here. If the first x that we have is 1, we'll say 1 squared. And our 1 squared is equal to 1. But is this 1 equal to 4? No, it is not. That gives you that this 1 is not part of the set. You can go to a 3. You say 3 squared, which is equal to a 9. Is 9 equal to 4? No, it is not. Therefore, 9 is not in that set. So you find that any odd number that you pick is not going to be equal to 4. Therefore, your set A is an empty set. Okay? Can now move on to the next heading, which is the subset. You say the subset is where we talked about a set being inside another set. So we can consider two sets, A and B. We say A is a subset of B if every element of B is also an element, if every element of A is also an element of B. You get that? We can say let A be equal to 1, 2, 3, and 4. We can also have B to be equal to 1, 2, 3, and 4. Let's look at these two sets. We are saying A is a subset of B if every element of A is also an element of B. So look at the two sets A and B. In A we have the element 1, which is also in B. We have the element 2, which is also in B. We have elements 3 and 4 that are also in set B. Therefore, since all the elements that we have in set B in set A are also in set B, you say that A is the subset of B. Okay? Equivalently, you are going to say that B. So you say equivalently, you say that B, set B, is the superset. Look at the notations of A. Like that. Let's consider another set. We introduce another set D. D is equal to 1 and 2. So now, is D a subset of A? Look at the definition. We are saying all the elements of D should be also the elements of A for it to be a subset. So in D we have 1, which is in A. In D we have 2, which is also in A. But A still have these other elements that are not in D. Therefore, you say that D is the proper subset of A. Equivalently, you say that A is the super subset of D, like that. So now, what will be the negation of this notation? So you say the negation of A being the subset of B is now going to be written as A is not the subset of B as a negation. If you're using supersets where you have B to be the superset of A, its negation is going to be that B is not the superset of A. Similarly, if it's a proper subset, you say A is the subset of B, its negation is going to be A is not the subset of B, like that. So I hope you are following with the pencil and pen. We can look at the examples. Let's look at the example that we have there. You have C is equal to that set, A is equal to that set. We also have B is equal to that set. Is A subset of C? So look at the elements that you have in A and the elements that you have in C. In A, we have the element 0. In A, you have the element 0 that is also in C. In A, you have the element 2 that is also in C. You have the element 4 that is also in C. Therefore, A is the subset of C. So it's a yes. Number 2, let's consider the sets A is equal to that, B is equal to that, and C is equal to that. So look at the more complicated set that we have here, set C, where we're saying set C has an element X. This X is a prime number, but it should be greater than 2. So you say this set is going to be equal to. So let's list this set. You remember it is given in set builder notation, so to easily understand this question, we are going to list the elements that we have in C. A prime number 2, 3, 4, 5, 2, 3, 5, 7, a number divisible by itself and a 1. So since it is greater than 2, we will not start with 2. Remember, strictly greater than 2. So we will not start with 2, but we'll start with a 3, go to a 5, go to a 7, and so on and so forth. Then you can ask, is C a subset of A? Now, set A has odd numbers. If you can see, you have a 1, 3, 5, 7. And you say any prime number that is greater than 2 is an odd number. Therefore, all the elements in C are going to be the elements of A. Therefore, C, is it a proper subset? No, it is not a proper subset, because every element of C is an element of A. Therefore, C is a subset of A. Okay? Consider also B. Is B the subset of A? In B we have 5. In A we have 5, yes. In B we have a 10. Do we have a 10 when we are dealing with odd numbers? No, we don't. So here you are going to say that 10 is a member of B. 10 belongs to B, but this 10 does not belong to A. For it to be a subset, we said that all the elements of B should be the elements of A. We can now look at the last example. Why is the empty set a subset of every set? So to understand this question, let's consider we have set A, we which is equal to 1, 2, and 3. We also have set B, which is equal to 1, 2, 3, and 4. We are saying that the empty set is a subset of every set. So you are saying, what you are simply saying is that this empty set is the subset of A. This empty set is the subset of B. So by definition, for B to be a subset of A, all the elements in B should be the elements in A. So in B, what we have is the element 1, which is quite alright in A, the element 2 and 3, quite alright in A. But this element 4 is not in A. And we say that since 4 is in B, but 4 is not in A, this implies that B is not a subset of A. This is by definition of a subset. Now, consider the empty set. Here is your empty set. If we list the empty set, it will just be open and close curly brackets. So now, for us to rule out that this empty set is not the subset of A, we should have an element here which is not in A. So, do we have any element in this empty set that is not in A? Pause the video and think about that. In this empty set, do we have an element that is not in A? Because by definition, if we have an element that is not in A, then empty set is not a subset. Therefore, since there is nothing here, we don't have an element that is not in A. Therefore, your empty set is the subset of A. There is no element in A in the empty set that is also not in this set. Therefore, empty set is the subset of A. Remember to like and subscribe to the channel so that we can move together in the next sessions, where we are now going to look at other definitions such as the equal and equivalent sets. For now, we can end here. Thank you so much.